Okay, shapes are congruent to each other if essentially they're identical. Okay, so they've got the same shape and size. So for instance, the triangle here, that is identical to this triangle. Okay, so they're congruent, and we can see that by using tracing paper. So I traced this earlier. Okay, the same shape is over there. It's just been rotated round. So if I rotate the tracing paper around, you can see it's exactly the same shape. Okay, so shapes can be rotated, okay, translated, so shifted across the page, rotated as I said, or even reflected. But if they're identical, then we call them congruent. Okay, so let's look at example here. Okay, let's look at the shapes. Let's identify the shapes that are congruent to the green shape here. Okay, so what I did earlier was trace the green shape. Okay, so I've got that trace there. So what we can do, as I said, we can rotate the tracing paper. For instance, if I rotate it here a quarter turn, okay, we'll have the shape there. Yeah, okay, so it's identical, isn't it? All right, so that one's congruent. What about this one down here? I could rotate it around this way again. Okay, and you can see that it's perfectly the same. Okay, so that one's congruent as well. Now clearly this one isn't congruent, isn't it? Because it's slightly longer here. It's not the same shape. Okay, that one is a different shape altogether. Yeah, we've got a rectangle there, so that's no good. And this shape is different, isn't it? Because it's larger in this area here. So that one isn't congruent. The one that is sort of awkward is this one here, because if I put the tracing paper on top of it, you can see that it's not the same. Yeah, okay. However, this shape is congruent because quite simply it is a reflection, okay, of this. So if I go back to this again, right, and if I were to reflect it, the reflect it means that you flip the tracing paper. Okay, so if I flip the tracing paper, you can see what the reflection would create, okay, which is exactly the same as the shape up here. So reflection can also be congruent. Okay, so let's look then at this. Write down all of the triangles here that are congruent to triangle ABC. So again, I traced this shape earlier, okay, ABC. So we've got that triangle there. Now I can just shift this tracing paper to see if I've got an identical shape here. Clearly that's not identical. Okay, so that one isn't congruent. Okay, now here maybe I need to rotate it. And you see if I rotate it, you'll see it's perfect, isn't it? It's perfectly the same. Okay, so the shape is identical. It's just been rotated around. So that one is congruent. Okay, now how I describe this is looking at the vertices, okay, corner points. So we'd go here, alphabetical order D, E, F. Okay, that's how I describe that triangle, just by going in order, alphabetical order, with the vertices there, the corner points. Now clearly that one isn't. You know, if you put the tracing paper above it, completely different triangle, and this one as well. Yeah, that one's not going to work. Now if I look at this one, okay, it kind of looks similar, but then it doesn't it? It kind of looks the same and it doesn't. But if I put the tracing paper above it, you could see it's not a match, isn't it? It's not a match. However, like I did in the first sheet, okay, if I flip it round, all right, I end up with it being perfect. Okay, so in effect this is a reflection of this. Okay, and going back here, if I was to reflect it, okay, flip that, okay, that's the sort of reflection image I get. It's just drawn down here, and you can see then it's perfectly the same. Okay, it's just a reflection of that shape. So it's the same shape, it's congruent. So to describe that shape, KLM, yeah.